Okay, I think we are live, and let me check something. Okay, the Weekend Hackathon is live. This is live. Okay. All right, hello everyone. So welcome to our March demo day for r/AI agents. We'll wait a couple minutes for people to trickle in, and then I will get started with the introduction, and then we will start with all of our demos. So for now, I'm just going to give it 1 or 2 minutes, let people kind of come in, and just, it's the start of the morning on a Saturday, so we'll wait a couple minutes here. Okay, so it's been a couple minutes. I think most people who are joining us from the beginning are here. So I'm going to give a quick intro on the community, who we are, what we do, and then we'll get into our first set of demos. So we are the r/AI agents community. This is a community run by OSS for AI. You can see the Luma calendar link here at the bottom, the OSS for AI Luma calendar link. That goes to all of our in-person events as well as our online events. You can also see here, I'm actually going to change the layout of the screen here. Okay. I don't like this. I'm going to do this. I'm going to go back to this. Okay. Oh, that's not what I wanted. This is what I wanted. Okay. You can also see the details for our community, our Reddit community. The r/AI agents Reddit community is the largest and most active online forum for AI agent discussion. As you can see, there's 4 million views monthly, over 4 million views a month. And there's 326,000 members with 2,000 posts a week and 20,000 comments every week. On top of this, one of the things that we want to do is we want to help support our community. And one of the ways that we do that is through running demo days like this. If you're familiar with the subreddit, you'll know that there are weekly threads where people can post about their projects. The weekly threads get thousands of views every week. They get a lot of upvotes. And that's where you can start to submit your projects and get into events like this. Today, we have 5 demos from the community. And each of these demos will run for 10 minutes total. And the ideal way to run these demos that we found is that you run the demo itself for about 5 minutes. And then we have some judges here. So judges, if you're already here, Sarab, I see that you're here. Judges, if you're already here, please do drop a comment in the chat so that we know that you're here. You should have received a voting form so that you can have all the votes and we can get out all the scores to people and the comments within 24 hours. The ideal way that we've seen that we run these is you have a 10-minute section, you have a 5-minute demo, and then we leave about 5 minutes from questions from the judges and the audience. Last month, we ran our demo day and we had 7 demos, and we had 1 winner from that demo, and that winner was Sakura. And you'll see that Sakura is now announced on the subreddit in our wiki as our February winner. So the winner this month will also be joining Sakura as one of the winners on the wiki. So that is about it from me. I know I scheduled about 10 minutes for intros. However, I am running a little early, and I see there are people who are supposed to be here to do the demos. So I will just get the demo started. And today we'll start with Make AI Clips. Oh, wait. Okay. Who is doing Make AI Clips? Let me find that. Wissam. Is Wissam here? Okay, Wissam is not here yet. So we'll skip that and we'll go straight to Peak with Encore. Okay. Encore, hopefully this time I know you have a big screen, so hopefully this time you get to zoom in and we'll see the full text on your screen. And you're on mute, by the way.
Hey, is it any way we could, I'm ready, but I'm just setting up my screen. I don't want to mess it up like last time. So can you give me like a few minutes, like five minutes just to get everything ready?
Sure. We will just go to Santosh then, and then we'll go from there. All right, Santosh, you're up.
Awesome. Thank you so much, folks. I'm going to share my screen. Okay. Hopefully you can see my screen. Fantastic. Folks, thank you so much for joining today. I am Santosh. I'm a senior principal engineer at Playlist. And my personal story is like in the age of agentic coding, we have a lot of coding tools and a lot of things are moving fast, which is fantastic, exciting times for all of us. But I found myself reviewing a lot of code with all those new coding agents in place, right? So people are able to generate more and we are able to produce more, which is all fantastic. But several times I found myself being the bottleneck because there is so much to review all the time. I tried a lot of coding tools, right? Or code review tools, if you will. Copilot, Greptile, CodeRabbit, Claude Code Review, Codex Review. None of them fit my needs because every team was different. I used to review at several different teams. I felt less in control. Lots of hidden models, SaaS offerings that would just take and hide and tell us not how the pipeline worked or how the code review tool itself worked. Sometimes it would catch really nice things, sometimes it wouldn't at all. So that was my inspiration where I wanted to build something that is highly customizable, open source, very transparent on how code reviews are being done. So with that, now the diff has become really long, and it is always is, and that's the problem that we're trying to attack. And being the bottleneck, I wanted to make sure that we have a transparent way to do it, not a per seat price. Code reviews are information processing, right? Just like any other agentic tools. So assigning a per seat price doesn't offer any value. And I didn't want a closed source system. I wanted to know what is happening behind the scenes on the code review. And if I wanted to tweak the gears, I want to be able to do it, right? So the initial offering of MergeWatch comes with a standard set of several agents. Here is the fun part. You can actually write your own custom agent and drop it into MergeWatch.yaml in your repositories, and you can extremely customize your code reviews, right? So we'll walk through a demo of all these things right now, and we can go on from there. Okay, so for today, for our demo, I'm going to show you a little application that I built. It's just like a game arcade, and you can see I have multiple fun games that some of them are not implemented, some of them are being implemented. And with that, let's go to this MergeWatch kitchen sink repository, and let's create a pull request. All right, so I'll open my Claude Code. Hey, can you create a branch and help me implement?
Can you zoom in a little bit?
Zoom in a little bit? Okay, absolutely. Is that good enough?
Maybe a little bit more.
Oh, sure, absolutely. But now?
Okay, that looks much better.
Okay, thank you. So let's go ahead and implement favorite pick. Sudoku. Okay. So now what Claude Code is trying to do is it is trying to implement the game arcade. And as part of this demo, what we are going to do is we will implement this functionality, create a pull request, and see actually MergeWatch kick in and do the review for us, right? And you could have a conversation with MergeWatch straight on the review thread itself. it does a few interesting things. I'll share you one of the reviews that I already prepared while this is baking. So here is a 2048 game that I built. I'm using Cloud Code, and this is what MergeWatch Review actually offers, right? It would build a very detailed map of what is happening and how this PR actually changes or improves or implements bug fixes, whatever that is, right? So for human absorption, most of us are visual learners, so it prioritizes that diagram first. You can customize this all in MergeWatch.yaml, and it doesn't slam information on your face, right? So it is optimized for human experience where I can come in and look at 1,000-line code and understand quickly what is happening and start reviewing it. So it tells, oh, hey, this is all looking good, but there is one potential warning that you want to take a look at and go fix it and everything else. So it gives you a ranking of 4 out of 5, and out of 5. And sometimes if it is 1, it absolutely says, hey, stop, tread carefully, and walk through it and make sure that everything is working fine. And that lets you confidently approach things, right? I'll also show some of the past code reviews that we have done, several of them, but here is a memory match game that you can take a look at and see there's been warnings. There is also things like Sudoku game. There's been a lot of back and forth where it would actually say, hey, this doesn't have any test coverage, but you specify that you need a test coverage. And it remembers between reviews. So if you look at the diagrams, it doesn't redo everything. It remembers between reviews and says, hey, you finished that one, but I found 6 new, and 1 was carried over, and all those things, right? So extremely customizable, extremely transparent. It even tells you how much tokens it used, what model it actually used. You can actually swap models in your MergeWatch.yaml and everything else. And very well integrated with GitHub, if you will. And it can actually help accelerate your code reviews in a very transparent way. Here is the kicker. You can take this and today self-host it within your organization completely free. There's nothing, everything is AGPL3, and you can use it today. And here is the dashboard that you get, right, for all the enabled repositories. As you can see, MergeWatch itself improves on itself with MergeWatch reviews. And you have very, very cool metrics that you can take a look at. For example, I'll show you the analytics. You can get to per watch analytics, like, is my Merge score trend getting better? As the coding agent that I'm using, is it getting better or worse, or whatever that is? Am I getting less security things, or I'm seeing a spike in the security reviews? You can do all sorts of analysis with it. You can selectively enable repositories, disable repositories. So much control and offerings with MergeWatch.yaml customization per repository, right? Model, draft PRs, custom agents, and everything else. So that being said, let's go back to our thing and said, hey, I implemented that. Can you submit a PR? Okay.
We are getting close to time. So judges, if you have any questions, please submit them. I think we'll have time to do 1 or 2.
Okay. Go for it.
All right. Question number 1 here. How are you handling false positives? Do I have a way to dismiss a suggestion so the agent learns and stops flagging similar issues? And have you tested this on large PRs over 100 files?
We did test this on a large PR over 100 files. So MergeWatch actually uses the selective pull from the GitHub. It can pull up to 3,000 files to actually do it. Today, there isn't a way to learn from the false positives, right? Inside the thread, it would acknowledge and say, this is false positive, I'm not going to surface it again. But the goal is to allow folks to actually use a vector database to index the entire repository and learn from all these things and make false positives much more capable later. But definitely that is in the plan, not right now. But false positives do occur occasionally.
Next, and probably the last question we can take for this is, what are your different customizations like, and can you show your example YAML file?
Yeah, absolutely. So we have docs.mergewatch.yaml, and here are some of the customizations that we can do. You can switch models. You can also use AWS Bedrock to select your own models.
Can you
specify
for this?
Yeah, sure, absolutely. Okay. So you can customize your prompts, agent, awareness. You can review scope, things that you want to ignore, and a few more others. But if you have requirements, we would love to take a look at it and see if we can add them to the customization options, if you will.
Okay. Thank you very much, Santosh. Thank you, judges. We will go to our next presenter. So, Ankur, are you ready?
Yeah. All right.
Okay, cool. We'll go to you.
All right. Can I go ahead and share my screen? Okay, let's do the entire screen. Sweet. All right. Thanks, guys. So last time, I want to make sure my screen is not blurry. Eugene, how am I doing?
This is much better. This is very readable.
Okay, great. I know it says Peak on there. They're very related, but we've been working on the name. It's very early days. So we're building SimForge. We provide infrastructure to iterate on non-deterministic code. The core problem we're trying to solve is we have found ourselves, my co-founder and I have built all kinds of AI systems. We've built memory systems, context engines, browser agents. We build an eval infrastructure product as well. And the biggest problem that we've consistently faced is for prompt tuning, search engines, we constantly have to tune knobs and kind of just pray that it works. And so we have been looking for a tool or a system that provides the infrastructure directly into our coding agents that has minimal or if not no dashboards, fits directly into our agent and allows us to iterate really quickly on experiments, but has the infrastructure hosted for us. So if you're building things that use probability, needs experimentation, and those are some of the examples here. We provide is a plugin that plugs directly into your coding agents. It gives you known primitives, things like traces, data sets, sandboxes. However, it packages it up in a way so that you can really effectively, your coding agent can use them really effectively. So you don't need, you can set up the whole thing straight through the plugin. You don't need to do, there's no clicks involved. In the back of that, we provide persisted and scalable infrastructure that allows you to be able to leverage those primitives and kind of put them together and wire them together for your own product. But we also package them in a way so you can instrument stuff really quickly, really easily. I'm going to just hop to a quick example of that. You would use, this is the plugin itself. I just want to make sure this is visible. And so in this case, you would just use SimForge instrument, and you would kind of describe what part of your code base you want to instrument the tracing for. It's already instrumented here, so I'm not going to run it, but just showing you an example of how simple that would be. You just explain what it is you want to instrument, and we provide skills that actually walk you through how to actually set that up. What is a good way to instrument tracing right inside of your code, and right inside of Claude Code or your coding agent. But the big part is being able to run improve. So in this case, we're actually going to have it run for peak memory extraction. This is a function that we have instrumented already. And what it's going to do now, it's essentially going to actually run and it's created a data set for all these failures that we have inspected or viewed in our data set for our traces for this particular method that we're working on. And it will create 10 or more experiments and try different versions of each one, and then and then basically show us a diff of which one worked the best, and then allow us to apply those changes using that remote infrastructure, that cloud infrastructure that's extremely durable and really well integrated into your coding agent. So I'm gonna let that run, and then we can just chat about it. Any questions? Or I guess I have to switch back. Did something happen here?
Yes, judges, if you have questions, please submit them. I see this. You probably want to zoom in a little. Not this. You probably want to zoom in a little bit more on this, and then we'll wait to see what kind of questions people have to ask.
Oh, it's in. There we go. It was on plan mode. Sorry. There you go. So there's a report popping up, right? It's basically opened up 10 different experiments to try on this particular function, and it has a I'll leave it to you guys.
I think you'll need to zoom in more on this as well.
I can just show you what the final result is, right? It'll take some time to run, but essentially we have, in this case, there's like 10 different experiments that were run on this particular method, and it's tracking each score. It's going to run all this in cloud infrastructure, and then finally pick in this case, there was a prompt that was improved, right? It actually tried 10 different prompts, 15 different prompts, and then ran that prompt against the data set, and then shows actually which one was the winner of all of these, which you can then easily apply right from this workflow.
Okay. Judges, please do submit your questions. In the meantime, Ankur, can you actually go into the results and click in to show us some of those different prompts?
Yeah, 1 sec. So, why is it not? Give me a moment here. Yeah. So yeah, we can jump into the agents. So it's running right now. So it's a little bit. This is a saved version of the report final. We would only be able to see like the prompts of the existing ones. I guess functionality we need to add in a cleaner way. But yeah, I guess this is it's running. It would be a little hard to do, I think, right now. Sorry.
Okay. Question from S Prasad 11. Ankur, how do you make sure when you run the same experiment, the results are accurate? I think this is like whether or not the results are repeatable. Yeah.
So as I kind of mentioned in this, so that there's a big part of this is data sets. The workflow, the plugin itself allows you to create and label data sets through your coding agent. So instead of like kind of manually going into UI and labeling things directly, you actually you actually have the agent will actually help you label data by pulling it a mix from your traces from your database, and then you can approve that data set. And when the run runs, it runs against that data set on each line. You can toggle it to run it like 5 or 10 times on a single row, so you can see that it's consistent, it's working well. On a consistent basis. And in fact, it can use that to be like, hey, this is, maybe we need to tune the temperature, maybe we need to tune the prompt or a heuristic or a hyperparameter to make things more stable. So yeah, for per line of the data set, you can run it multiple times. It's a great question.
Okay. Any other questions? We still have time for 1 or 2 questions here.
All right. Well, yeah, I mean, happy to take any more questions, but also the infra is live today, releasing the plugin next week. We're looking for the earliest teams to help help us for us to help you guys move faster.
Awesome. Okay. Next up, we will have our next presenter, and our next presenter will be Bala with microbots.
Hi folks, hello everyone. Thank you for having me here. Let me share my screen quickly. Yes, share the screen. Entire screen. Please let me know if my screen is visible. Yeah, I hope it is visible now.
Yep.
Yes, thank you. So actually, I'm a principal software engineer in Microsoft, and we have created agent framework which is completely open source. Actually, we are not a startup or we are not creating a product out of this. We found something will be useful, like we are developing multiple agents internally, and we thought, okay, we are doing too much housekeeping work for creating an agent. For example, we used to create agent for backporting a patch, we used to create agent for analyzing a failure logs and so on. So but there are so many common things among multiple agents, but every time we are creating a new agent, we are redoing the same work. That's why we created this framework microbots. So here you can simply create an agent with just 2 lines of code. Just we'll go with the quickly demo. Let's say there's a simple bug in this code. It's a C program. You can see there's a bug in this line. There is a single quotes instead of double quotes. Okay, so usually we'll use VS Code. We'll call the agent. It will identify the bug and say that. How to do this in full automation? Let's say it is happening in a Jenkins job or it is running on a Azure pipeline. So how easy for you to create an agent? If you use microbots, you just need to simply import an agent from microbots, and this is just for log analysis, log creation. And you create a bot. You first say what model you are going to use and which source directory you want to do the debugging. And then next you run the bot, you run the agent and say what is the task it has to accomplish. So you're saying run using this GCC, the buggy code.c, and fix the compilation error, and the timeout is 5 minutes, and you can simply execute. So we have just created a bot in hardly like 5-6 lines of code. So the log started spinning up. I'll show what is happening here. You can see at first it is exploring the directory, and then it is reading the file, the buggy code.c, and agent determines, okay, it is even running the code to understand the compilation error. So it got the compilation error in the std out. Then it is updating the file because it has read the file, it knows where the error is, using a set command to update that. Once again recompiling for the verification. This time no compilation error. So the agent said task is completed, it has given it back. So we can see here the updated code with the fix. So why we have done this? There are so many agents, right? Like the reason is how easy to create an agent. So it is not like only for code writing. You can do it for log analysis. You can do it for writing the documentation. You can do it for doing the PR analysis. Like you can even put a patch file, ask the bot to check for any compilation errors or any other regressions you may anticipate. So the internals are handled by the library itself. You just need to focus only on the task. So we reduce the developer toil here. And right now this is actually hosted as a Python library. You can simply do pip install microbots, and you can immediately create agents in just 3-4 lines of code. So this comes with some basic agents. We call it as reading bot. If you want to give only read only permission, you don't want the agent to update your code file, you don't want it to write or modify anything in your code base, then you can use reading bot. You want it to fix something, you can call the writing bot. You don't want to do any task in the local code, but you want to fetch some information. Let's say you want to get some information about a CVE in the internet, you can use browsing bot for that. And there is a log analysis bot because we predominantly use log analysis, so we created a specific bot for log analysis itself. So again, the code is going to be very simple. So reading bot is just like you create the agent and then you run the agent and you set the task when you are running the agent. Sorry. The system prompt, the tools, everything is already handled in the background. Similarly, to update the code, you can create a writing bot. Same syntax is same. You are going to tell what model you want to use and which directory the agent is going to work and what is the task, what is the timeout. Suppose you want to have full customization, you want to create your own agent. So still you can able to do that. You can tell, you can even override your system prompt. So just I put a simple example here. You can have very elaborate detailed system prompt which is very specific to your code base, your internal knowledge, everything you put it there. Additionally, you can even control how many iterations it has to make with the LLM. So I will show you. You can add your own custom tools. Suppose you want to do a crash analysis or a packet time analysis. You can host a tool. You can add a tool into the agent. So immediately you can simply hook up new tools and you can create agents in no time. And the important crucial factor of microbots is security. Why? Because this is the architecture of microbots. So every time you create an agent, so it is not going to work on your host machine. So that's why we are telling which directory it is going to work. The entire file system is not given to the agent. So actually when the agent is being created, in the background, the ephemeral container is created, a Docker container is created. Inside the Docker container, all the code base is only RO mounted. On top of it, you create an overlay file system. On top of it, you create a console session. And all the connection, all the communication from the LLM, all the commands are actually being verified. So we have a regex based security check. We don't want to have any bad commands to go inside the ephemeral container also. We do the check here and we execute that only inside the container. So your original code or original log file will still pristine. It will not get affected. This is very important because we are going to host it in a full automation mode, like in a Jenkins job, and error happens in the midnight. When you come in the morning and see, you don't want the agent to delete your original log file. So you want to see the agent log summary also. At the same time, you don't want to lose the original code or original build files. That's why we create this kind of model, and it is completely secure. Additionally, if you want to add your own tools, so you can pass a tool, something like additional tool. You can create a tool. A tool in microbots is a data class. I'll just zoom in a bit. So you can simply say the name of the tool, the description, and how to install the tool inside the Docker, and how to verify whether the tool is properly installed or not. And these are the instructions for the LLM to use, how to use the tool. And these instructions will be naturally appended into system prompt before the agent is being invoked. So then once you create the tool, you can simply pass the tool as an additional tool to the agent. And now suddenly your agent gets a new tool at its disposal. And that's just because it is a data class. You don't even need to create in Python. You can create a YAML file and you can keep multiple YAML file, multiple version of a same tool, and you can simply add it into the microbots. We already given a parser function. So you can pass the YAML file to the parser function, and then that will create a tool. You can pass the tool to the agent anytime.
Okay, you have a lot of questions.
And why we have created? Yes, please.
Let's get to the questions here because you are running up on the time here. So,
Cool.
Sujatali asks, when the agentic loop fails mid-run, what does the developer actually see, and is there a structured trace of every LLM call, command, and container output?
Exactly. So I will show you. We have run this current job, right? You can go to the logs. You can see every single step agent has taken. So initially, even if it crashes, the log stays. So it explores the code base, it reads the code. So everything it stays there. And debugging log, you can see like lots of things, what happens internally, what actually happened during the time of container creation, everything. So everything stays back for your to use that, and you can debug using that.
Cool. How do you handle prompt injections or malicious commands? And will there be access provision for the bot to write versus read?
Yes, so the reading bot will have only the read-only permission. If you see here, so this all the files are mounted into the direct container, but inside the files will not be modified. So even if there are any modification commands, that will not be affected outside because it is mounted using overlay FS. So any modification happens inside the Docker will not reflect the original host file. So the permission is very critical here. We don't want the original files to be updated, modified. And regarding the prompt injection and that part, to be frank, we don't have any restriction because this is for the developers and we give full prompt whatever they can use. But when the LLM tries to run some bad commands like rmf and rf, or it wants to delete the database, those commands will be interpreted before even sending into the Docker container. So LLM cannot able to run any malicious command.
who defines the verification rules? Are they static and they're in the library, or is that something that developers should define?
So there is a default regex pattern is there, and that is still extendable. Everything is modularized in microbots. So the environment, the tools, the LLM, and the entire bot loop, agentic loop, the React loop, and the tool verification, everything is modularized. You can see in the documentation in detail. So you can add your own rule, you can replace existing rule. It's completely on developer's control.
Do you have a denialist or some type of human in the loop integration?
Right now, we don't go into that model because mostly we are focusing on workflow integration. So let's say it is going to be running in a pipeline or it is going to running in a Jenkins job. So this is a normal flow. When the test fails, we want the bot to be triggered. So we create a new bot and agent, and that agent is going to be conditional triggered. And mostly it is going to happen when the human is not there. So we want to have the agent to run and produce its result before even we have a first para human eye looking into the failures. So that is a agenda. That's why we didn't so far add any human in the loop model yet.
How does containerizing affect latency compared to running agents directly?
We didn't see much latency here because the container is running locally. We didn't try any remote container issues so far. And we have HTTP server running inside the container, and connecting with that is actually having very less time. The LLM interaction is actually taking more time in seconds, but the container interaction is in microseconds, if not milliseconds.
And how are you measuring accuracy when they run multiple times to ensure consistent and correct outcomes?
That is one of the biggest challenge we have. So we have to do multiple iteration and refine the prompt. The system prompt is so big, so we try to customize the system prompt for every workload, and that is a bigger challenge. And if you see the bot workflow, we don't try to give the whole task to a single agent. So we try to break that into multiple agents. Yes, I may have some example here. Microbot. So not here. Yeah, this workflow if you see. So some issue has happened. I'm not asking LLM, okay, go and fix whatever it requests. First, I'm going to deploy reading bot just to read and give me a summary. Then that summary is going to a next agent, writing bot. And then maybe I may need another data. Okay, I will add a browser, go to the internet, fetch some more data, then feed both data to the writing bot. So here the recommendation for any developer is you have a simple agent, and that should do only one job. Don't overload it, because we see lots of failure when we mostly overload. If you give one task at a time, we see more success ratio. And after, integrate multiple agents using programming.
Okay, last question, and then we'll move on. What happens when the agent's fix introduces a new bug? Has that happened, and how did you find out?
Yes, that actually happens not very many times. But what we do is we have a agentic loop. Every workflow is not only with a single agent. We have a actual agent, we have a review agent, and then there's an actual build workflow which actually verifies that and feedbacks to the other agent. And we don't do that indefinitely also. We try for 2 or 3 retries, try to fix it. If agent is creating newer bug, we don't take that. Sometimes we have to completely abandon that and leave it for humans to come and verify that.
Okay. All right. Thank you very much. Thank you very much, Paula. We'll go to our next presenter. Okay, Arjun and
Bhavani.
Bhavani. Okay, cool. You guys.
Yeah, thank you. Let me just start sharing. Yeah, so we're really excited to present Roverbook, which is Multibook for websites. So you have Multibook tick off because you have agents leaving comments, threads, posts on like a single forum, but you have a website that has a ton of agentic visitors, and you're not collecting any of the trajectories, any of the responses, feedback from these agent visitors. So it started off as a fun side quest at a Google DeepMind hackathon last week, and we built out Roverbook, where you just add a tag to your website. Not only do you have an agent that can take actions, but it can leave guidance to how to leave feedback for agentic visitors, as well as track trajectories and surface it in a post-hog-like analytics dashboard for your website to capture agent analytics, like of AX, agent experience. So you can check it out here. We've also open sourced the repo, but the key thing is agents. You collect how they're taking actions on your site, as well as collect feedback of reviews that they might leave or notes that if they come back in the future to your site, they can understand what worked last time or what to know for a future interaction.
Also, as a quick context, so what we built is Rover. Rover turns any web interface, old or new, into an AI agent with just one line of code. And how do we do that? All you as a website owner or product owner have to do is put this script tag on your website, very similar to like Google Analytics script tag or like a Twitter Analytics tag as such. And with that, Rover sits inside your web interfaces, and it not only answers the questions that user got, but also takes actions seamlessly end to end. Like a quick demo would be, let's say you got an e-commerce store. We can play it on our Retriever website too shortly. So like, yeah, you can see the Rover right there. You can customize it as per your website. You can do a lot of configurations of like what pages you don't want to be automated by the agent, or what kind of action. Suppose you don't want like a scroll action as such. And you can also, do you want to allow third party sites or do you not want to allow third party sites? I'll show all of it shortly. For example, I'm like, go add a vase under like $200, probably lamp, and let's say, let's do this, and like ship to urgency at I don't know, like Mina Street, SF, something, right? So it automatically like scrolls, types, clicks, does everything without you as a product owner or website owner exposing any APIs, MCP, or even like maintaining or creating any RAG pipeline. It acts real time on your pages in milliseconds, take actions. As you can see, it's already shopping for us. It will take actions, and the best part, it can run in the background. And you as a user, when you're like switching around, you obviously do some task, you switch some tab, but Rover will still run in the background of like completing the process for us. It's in the checkout page. It's like adjusting the count of the products. It understands and adjusts the trajectories of the agent. Now, this is great. You're making your interface more usable for humans in the AI world. Like humans these days are no longer interested to figuring out where is what, how do I run this workflow, how do I do this dashboard. You just go to Claude and Cursors of the world of like, hey, how can I build this API? Now, by putting this one line of code on your website, now you make it like ready for the humans of the world today. They can speak to you or talk to your website and get things done at a higher accuracy and extremely high speed. Now, this is great. What about AI visiting your site? The same tag will also enable AI to trigger Rover on your website. As simple as such of like, go to like Retriever AI, Rover equals, hey, launch me a cloud browser. Hey, get me this subscription. So your AI no longer have to like launch Playwrights and like click, type, do stuff. They can literally trigger Rover on your site. And not just that, with that, we capture a lot of analytics of like agent, like what is the total success rate? What are different sessions? And what are the trajectories that the agent took? And the most important part, like, yeah, Moldbook style or your Google Play Store app store style, agents visiting your site, your Codex, your Clouds of the world can come, leave a review, rating of their experience. And the coolest part is like a memory sticky notes. Like we ID the agents visiting your site, and then the agents can like leave a memory for them. Oh, last time I came here, I clicked this to get the pricing. And then they can like speed up this task next time they're here because the memory goes straight up into the same ID'd agent. And one more coolest thing is like, you guys might be familiar in the traditional world today, there is user interviews, user research for your website. But what about agents? Because agents traffic is going to surpass humans by 27, right? So you can also drop your interview questions that we surface via dedicated agent protocol for the AI visiting your site. And these AI can like take answers to them so that you can improve build experience of your products based on this.
So you saw there's a lot of Codex interactions. So we actually went to Codex and asked it to, hey, go to this website,
Get me
a
the
review.
pricing and leave a review.
So Codex opened that URL that we have this demo website in a
And calling the methods exposed by Rover. And not just that, we also expose window methods of like WebMCP. If any of you are familiar with like Google WebMCP, what they want to do is they want you to expose certain window methods. And not just that, they're basically you're registering tools, just like for any AI. And the tools will do certain actions. Now you are responsible for exposing database APIs, JavaScript APIs to like expose those tools. But with Rover, we expose methods directly and make you WebMCP compatible. And you can like, and how do we do that? You can check the total code that you're going to put in your website is fully open source of like what are different methods exposed by Rover book to the AI, what are different analytics, how do we ID these agents. These are the explicit tools we have of like leaving the review, leaving a memory note. We also have, this is a thing of like Reddit style or Molebook style of agents can come and post, other agents can reply, upvote. So all these methods are pretty explicitly exposed for AI to like find it and like call these. And this is the WebMCP part I mentioned of like we have dedicated methods, so you don't have to like expose anything more and make the work and keep on updating or maintaining them. We expose the key tasks that an AI need. Run task is the main task that AI can put any query they want, and Rover will actually do the task for them. If they just want like a curl style of like get the page data, whatever it's on certain URL, that's that, as well as agent nodes, feedback, all of these things. Yeah, do give it. We are continuously improving this. We are already got 50 stars since like a couple, like 1 week ago. Give it a try. Give your feedback. Happy if you can open PRs as well. We want to bring transparency to what you put on your website. It will still call our backend that constructs the state of the art, what we call as like DOM semantic trees that yields this high accuracy of like understanding the web pages, even with the smallest models out there. Whatever you're seeing is with Gemini Flash and Gemini Flashlight, yet gives you the best accuracy possible.
Cool. You guys also have quite a lot of questions here. So I think first one is this one. You framed this as post-hog for AI agents. What is the actual data infrastructure behind Roverbook, and what happens or what breaks if agent traffic spikes 100 times?
Yeah, so we're ex-Googlers. We built the entire thing on Google Cloud. So it should scale pretty fine.
So we have cloud functions. These post methods, the console methods that the AI is calling is tied to the post calls, triggering. So it's scalable as per these requests. And for databases or storage, we split across Firestore as well as Firebase storage. So based on the importance of the task, what metadata we put in the main database and dump it in the S3 style storage. So all of these are like scalable and sharded based on the site IDs, UIDs. So these agent traffic goes like in a scalable way across these collections rather than having one hot collection. So that should like hopefully like handle well. So far we have already 2,000 installs of like Rover on a lot of small website owners or wipe coded apps, and so far it's like pretty stable. It has been pretty stable.
Cool. When an agent visits a site through Rover, is it rendering the page or is it parsing the raw HTML? Because what happens if the site is heavily, JavaScript rendered?
There are both of these can happen. So ideally, like a lot of these Codex you saw, right? They launched Playwright Interactive, and even like Claude tries to like spin up their own browser infrastructure. So yeah, render the page and it was just passing raw HTML. So because Rover sits in the script tag, no matter dynamic JavaScript or not, and it sits in your main layout page if you're familiar with Next.js, or it's literally head of the way you put the Google script tag, so it will be loaded.
Agent isn't visiting through Rover. Rover is an embeddable script tag that is added to your website. So when an agent opens your site in a browser, they'll have the instructions through the script tag on how to call.
So it is loaded in the main head page. So it is loaded before any of this other dynamic JavaScript content. So the methods exposed, the protocol exposed will always be visible to the AI. And AI can also directly call us via post call without any real browser infrastructure. We have like a skill for any site that has Rover enabled, how to simply just call that website and put your prompt. That's it.
Cool. how does it handle dynamic pages where the DOM changes with each click? And what happens if it encounters something that it can't figure out? Is there a way to scope what parts of the page the agent can access?
So we built out a state-of-the-art AI web agent underlying technology that parses the DOM and represents it as semantic trees to models. And now we're just doing it from inside your website. So after it takes the action, it waits a second and then parses the new state of the DOM. So we haven't had any issues with the DOM
so
changes.
we have various heuristics on like identifying the dynamic content. Do we need to wait for it, or do we need to take certain action of like scrolling, clicking to make sure, based on the workflow and that sub agent, we need to make sure the JS content is loaded, and the agent is capable of using various tools first to make sure the content is loaded before or after certain action, and then proceeds with the next step. And just as you saw, it's completely self-healing. If something has happened at a certain step of like added more things to the cart, or let's say it decided it needs to like go back if it encountered 404, so it recovers and like tries to like complete the task. And you as a website owner, when you get onboarded, you can exclude certain pages, as I mentioned, as a blacklist for the agent on your site. If you have domains and subdomains, you get also control on, do you want rover across all your domains and subdomains, or only on subdomains, or only main domain? So you get a lot of things. You can get onboarded in 1 second, or you can spend like 1 minute to like review various, we expose a lot of configurations for you to have more controls.
What percentage of real agent traffic today self-identifies versus you having to guess that it's an agent?
Yeah, so again, we are not building your Cloudflare or Datadog, so we don't have a lot of these heuristics of like, oh, this IP belongs to Perplexity, this IP belongs to like ChatGPT. So like, yeah, we are pretty clear on what we have. So the ID we have today is self-identification by these agents, or from the headers that your website receives from these agents. Like if you are on like some hosting like DigitalOcean, Vercel, or wherever it is, they do pass the X agent header. So whatever is passed, whatever is self-identified by AI, we don't have like our own.
It's voluntary. We think in the long term, websites can offer agents for more information, or it's in the agent's best interest for better performance, hey, if I'm like identified as Gemini, it would be easier for me to navigate.
And also get back to your memory. Yeah, so it can like recollect its memory when it's leaving memory for itself, all those things.
And that's a great segue into the next question, which is who controls the memory for the memory nodes for the agents, and what about how do you handle like bad actors and what position and permissions?
Yeah, so it is configurable as you, the website owner, to expose it. It's still an experimental thing. We're just excited to see what people will do with it. But yeah, there's two types of memory. There's shared memory for like all the agents visiting your site, as well as private memory.
ID specific memory. So as you can see, yeah, sorry, I'll share the screen real quick. You also asked earlier of like, how much of it is like ID'd and versus not ID'd. So for example, this run, it's anonymous. So there is no ID of this agent. So if it uses the same, it's anonymous. So this memory won't go into the agent. So we have, as Arjun mentioned, shared memory that various agents can use. Or if an agent is ID'd and the same ID'd agent comes back, this goes into the memory of only that specific agent. So the memory is completely by AI, and it goes into the AI only if it's ID'd with the same way. Yeah.
Okay, I think this is our last question. So shared memory is interesting. How do you think about keeping signal high quality over time with scale?
Yeah, I think it will definitely, we'll have to do like progressive disclosure, only the top rated shared memory comments, or like with higher trusted signals, like agents with higher signal. I think that's what we will end up going towards. Kind of like when you do a Google search, Google only shows you the top like index stuff.
Yeah, this is definitely something we haven't thought yet because it's very in the early phase. Yeah, happy if you want to like leave a note on the GitHub repo. We would love to like brainstorm more on
or get your agent to leave a note.
Yeah. Okay. All right. Thank you guys, everyone. Thank you to all the presenters. Thank you for all the people, all the judges, everyone who came today. We will get all of the judges. Please do submit all of your ratings. You should have the forms, and we will get all of the forms collated. Or sorry, I I don't know. We'll get all the forms put together, and then we'll get all the scores out and all the comments out to the presenters, and we will get the winners announced within 24 hours. So thank you guys all very much, and I'll see you guys next month.